Hello everyone, welcome once again to another video of Slidescope where we are learning health analysis with Python Pandas on blood test data. So this is a sample blood test data which I have already uploaded on my website. So from here you can download the data and you can also get the previous part's code. So this is part 2 of our discussion. In part 1, we discussed how to read data, how to create a data frame, what is a data frame, and various things related to basics of Python Pandas. Like we read methods like head, tail, we read how to select one column, we also read how to select multiple columns. So we did all of this. Then we also discussed plotting simple graphs like a histogram plot. Uh, Histogram plot is used to see how the data is distributed in a numerical variable. So for example, age is a variable here and how the data is distributed here. That was discussed last time. We also saw using value underscore counts method. So use value underscore counts method simply takes a categorical column. Whenever we have a categorical column, so in that categorical column, for example, gender is a categorical column where we have only two values. So for every data row, we can either have a male or a female value. In this data set, we only have these two values. So value underscore count will give you count of those individual values in all rows. Now using value underscore counts, so up to this part, the result that you will get is a series. A series is a single dimension data and a data frame is two-dimensional data. So you will get a series. In this series, index is male and female. This is index, and 25 and 25 are the values of the series. So this is not a data frame but a series. And using this series, we can also plot a pie chart. So when you will plot a pie chart, you will see that it will distribute the data in two parts. Now here we also have one more categorical column, and the column is are they sick or is unwell, whatever you want to call it. So let's start today's discussion moving further with this project. So we are starting the part 2 here, and many more parts may come for this video. So stay tuned to our channel and make sure you have already watched the part 1. So after viewing the part 1, you will understand this clearly. It is on our channel color stick. So okay, it is very simple. And now let's start the part 2, and in part 2 we will learn various other methods and some other properties related to graphs. So when we plot a pie chart, first of all, so a pie chart can be plotted on any categorical column. So here we also have a column called are they sick. This is or is unwell. So first I will make sure what is the exact name of that column in my case. So I will insert a code here, and to find out names of your column, just write data dot columns. So data is your data frame and these are the name of our columns, and it is unwell. This particular column also has binary values, right? 0 or 1. So in order to check that, we can write data square bracket then name of this column. This is how I taught you how to select one column from a data frame. So this is how you will select one column and then you will write, and then you can see the values. So these are the values. Now using value underscore counts, we can find out how many people are unwell and how many people are, let's say, healthy. So again, you can use value underscore counts and you will see the answer. So in our current data, 28 people are unwell and 22 patients are healthy. So this is how the data is distributed. So you can use this column to create a graph here as well. And when you will create a graph, you will see 28 and 22. Now let's say we want to show the percentage of these segments. What is the percentage of unwell people here and what is the percentage of healthy people? So there is another parameter here called auto PCT, and in auto PCT we can write, because we have to find percent, so we will write percent point to f, and when you will do this you will see that 56 and 44 is the ratio of unwell and healthy people respectively. So this is how you can find out percentage in pie chart. On these graphs you can also create a bar graph very easily. So when your data is a series like this, where your index is 0 and 1, that these are the values, and 28 and 22 are the respective counts, and you can use dot plot and kind is equal to bar. So this is the easiest way of plotting this graph. Now when you have used kind is equal to bar, so in this case you can use another parameter called color, and you can create a list here, because we have two bars here, so we can choose two colors here. So we can choose something like R and G. So this simply means red and green. Currently the bars are blue only. Let's see. So here you can see R and G. And you can also use HTML color codes here. So for example, we can use something like hashtag triple E, hashtag triple zero. So these are two HTML color codes, hexadecimal codes, and you can see. So if you want to find out more HTML codes, there is this website called htmlcolorcodes.com, and you can find out more colors here. Suppose we want this color, so just copy the color here and put its hexadecimal value here, and you will be able to use that color in your graphs. So this is how you can customize your graphs by using the default plot of pandas. There is one more way of plotting this graph. So currently we have used plot method, and in the plot method we have used these parameters and with their values. So, but what we can do is we can also write it like dot plot dot bar. This is also another way of plotting a bar graph. So So here only there is only one mistake, that with plot we don't have to use the parenthesis. So this way you can plot a bar graph, and now you can put your argument parameters here. So for example, color is equal to R Y. So, so red and yellow, this is what it is representing. So this is how you can customize these graphs. Suppose you want to put a title to your graph. So there is this parameter called title, and this will simply put a title over your graph. We can also write something like X label is unwell. So you can see X label and similarly Y label, because there is count. So count. So this is how you can customize your graph. Suppose you want to change the size of your graph. So one parameter is fixed size. And in fixed size, we have to again use a list. And in the list, you have to provide the X and Y parameters. So let's say I want my graph to have a length of 7 units and height of 2 units only. So you will see a small graph. So it depends upon where you have to put this graph. You can customize your parameters. So now after learning the basic type of graphs, let's see which columns are unnecessary in the data set and let's drop them. So first we will write data.head, which will give us these values. Like this will give us the data frame with top 5 rows. And what we can do here is we can see that patient name is unnecessary. It is not needed for analysis, because in analysis we choose only those columns where we can summarize data. For example, age, gender, or this column is unwell. So let's try to drop a column. So to drop a column, just write data.drop and here create a list, and in the list put the index. So the when I say index, so this column name is actually the index of that one, right? So here you will write patient name, and then you have to provide another parameter called axis. Okay, so for row axis is 0, and for columns axis integer value of axis is 1. So for columns, so because we want to drop a column from our data frame, so that's why we are writing axis is equal to 1. And when you will do this, you will see that column does not exist anymore. But here's a trick. This is just an output. It is showing us what the data frame will look like without this column. So even if we use data to see our data right now, you will see that column. Okay, so this column is not dropped, but we have simply created a copy of this. So what we can do, there are two ways of doing this. So if we want to permanently drop this column, just write in place is equal to true. Now this column will be replaced. Okay, this column will be removed from the data frame, and this is one way. Other way is we can also write it like this: data is equal to data dot drop. So whatever the output of this particular expression is, we are this particular expression's output, we are saving it into this variable. So let's call it df just for understanding. So now after dropping the patient name, we have stored a copy in a variable called df, which we mostly use in pandas to call a data frame. So now when you will write df, you will see that patient column is patient name column is not visible. Now next step is to use another method to see the correlation of values. How these numerical values are correlated with each other, like how hemoglobin is related to WBC. If you remember our last discussion, the target variable in this case is unwell, or we can say the output variable is unwell, and these are all input variables. So on the combination or with the combination of these values, it is decided that if the person or the patient is well or unwell. Like if their hemoglobin is more or less, are they unwell? Suppose your hemoglobin is less than a specified limit, then that means you are unwell. If your platelet counts are less, that means you are unwell. In fevers like dengue or maybe sometimes in other type of fevers, uh, most of times platelets get dropped. So that's why by that's why it is asked for to inject platelets so that their platelet count may increase. So that's why we want to test are these columns related with each other. So here we can use a column called df.corr. So this method called corr. So what this does is it computes pairwise correlation of columns excluding the null values. And here we can also use Pearson, Kendall or Spearman method, but we will not use these methods. This is a standard correlation constant, then Kendall tau correlation constant or Spearman rank correlation. So this time we will simply use this df.corr, and when you will write this, you will see a matrix, and in this matrix you can see first you have age, hemoglobin, WBC and all, and here is unwell is written. Now how can we read this? What is the correlation of age on is unwell? 0.76. Hemoglobin on is unwell 0.85. WBC 0.81. Okay, so you can see it is cholesterol which has the least value. So this simply means if hemoglobin is correlated with being unwell. So if someone is unwell, that means hemoglobin has something to do with it. Here you can also read correlation coefficient 1 is perfect positive correlation. A correlation coefficient of 1 indicates a perfect positive correlation. A variable x increases, variable y increases. As the variable x decreases, variable y decreases. So a correlation coefficient of -1 indicates a perfect negative correlation. So in our case, you can see these values are close to 1. So this is how we can find out correlation. So now there is one more way of viewing this in a graphical format. So there is another library which is called Seaborn. So this is also used to plot graphs. So import Seaborn as SNS, and in Seaborn library there is a graph called heat map. So this heat map, in heat map you can provide a metric like this. So when you will provide this, it is plotting the graph, and now you can see. So this is the graphical representation of this same data, and here also you can see a lighter shade means 1 and a darker shade means less. So this is how it is represented. So cholesterol and is unwell have less value, less correlation. Is unwell and age have a mid correlation somewhere around zero point 0.8 and so on. So this is how you can read the data. The variable with itself will have the highest correlation because that is natural. That's why you can see in diagonal you have the lightest color. So this is how you can draw a correlation plot, and this is a simple demonstration where we discussed about how we can find correlation between variables. Now suppose you want to see if you increase hemoglobin, will platelets count also increase? Okay. So in order to do that, we have various ways of doing it. So first we will try something. So the simplest way of doing it is using a scatter plot. So scatter plot is used to plot a graph between two variables and see how they are related with each other. So how can we plot a scatter plot in a data frame? So in df we will write df dot plot dot scatter. We can also use kind is equal to scatter, but this is also another way of plotting a scatter plot. And here you can see the arguments that it is taking is x and y. Okay, so we will write x is equal to something and y is equal to something. So for x, first we will copy the exact name and put it inside curly brackets. So let me do it once again. And similarly, let's say platelets. We want to see, suppose when someone is unwell, suppose we sometimes doctors suggest for blood transfusion. So to increase hemoglobin and to increase platelet. Let's see are these two values related with each other. So as per the data set, so you can see here when the value of hemoglobin is increasing, the value of platelets is also increasing. So suppose from our complete data set, if we take it only these two variables and call x as our input variable and y as our output variable, so we can also find out, we can also plot a line between these variables. We can apply linear regression here. So on our channel, we have many videos related to linear regression. So if you want to go into the theory of linear regression, how it works, I will provide a link. I have I have explained the concept here, and I have used multiple tools to apply linear regression, like how can we apply it in Power BI, how can we apply it in Tableau, how can we apply it in Python. So you can see these videos. So we can apply linear regression here. So again, this is not the original task, but let's say while analyzing we got this task and we can see that by increasing hemoglobin, platelet counts are increasing, and we want to draw, or we want to put a perfect line between these scatter plots, as they are not in uh, you can see these values are not in a perfect straight line, but with the help of linear regression we can put a line that will kind of represent the relation. So we can use that line to find out value of platelets for any given value of hemoglobin. So a regression line is an estimate of the line that describes the true but unknown linear relationship between two variables. So we don't know that linear relationship. Suppose by increasing hemoglobin, we can say we knew with what function uh, the value of platelet was increasing. Let's say platelet is 100 times hemoglobin. So in that case we know 100 times, but here we don't know that. So that's why we will put a line here. So in order to do that, we'll use from sklearn, we'll import linear model. So this is how you can import the linear model. Now after importing linear model, you have to take input and output. So input in our case is hemoglobin, and you have to remember one thing: the shape of input should be two-dimensional and the shape of output should be one-dimensional. So I'm just writing input 2D. These are also called feature variables, and output 1D. This is also called a target variables. In our case, we only have one, but still the shape should be two-dimensional and one-dimensional. So let's say we'll call it HB, hemoglobin, and we'll use DF. We'll use two square brackets and select hemoglobin. So with the help of two square brackets, the output will always be a data frame. And let's print it also to see. You can see the output is a data frame. So this is how you will select your input in linear regression. Then similarly, you will also draw platelets. So let's say PLT, or we will not use PLT because most of the time we use it for matplotlib. Let's say PL. So now DF and only one is square bracket, and here let's okay. So it is giving us a suggestion. So let's select the suggestion. Now it's not giving. I'll just copy, and this is going to be our output, input and output. Now when you will write PL, so you can see this is one dimensional and this is a series. Okay, so input or inputs should be 2D, a data frame, and output should be a series. Let's write just head here so that it doesn't take a lot of space. Now we will create linear regression object. So this particular expression, using the linear model and then using linear regression, we will create this object. So using for this class linear regression, this reg is an object, and then in this reg, or we can call it a regressor, whatever you want to call it, we can fit the input and output values. So we will simply fit reg.fit HB comma PL. So we are fitting hemoglobin and platelet, and here you can see linear regression has been applied, and reg dot intercept. With this property, you can find out intercept and reg dot corr. With this property, you can find out the coefficient. So what this particularly means is, if you remember, the equation of line is y is equal to mx plus b or mx plus c, where b is the intercept, and m is the slope or coefficient in this case. So in this line, suppose, and by the way, y is, so this line will be something like PL is equal to m times x, which is hemoglobin, plus b. So now with this equation you can find, so b is nothing but this, m is nothing but this coefficient. So we'll use it. Since it's an array, we'll use 0 here. to select it. So this is something from equation. And for any value of hemoglobin, let's say if hemoglobin is 14.5, then predict PL, that means platelet. And so either you can use this particular way, the equation of line, or what you can do is you can write reg.predict, and you'll use two square brackets, and then you write your hemoglobin value, let's say 11.2. Two square brackets, as I said, the x or the input is always a two-dimensional value. So this is giving us an output 171.46. So this is how you will find out y, or you can use the equation. So in this particular part of the video, we the main purpose was to teach you a bit of linear regression, how it can be applied. This is a machine learning algorithm of supervised machine learning type, and we have a lot more to discuss with the help of this particular blood test data that we have. So just follow the tutorial, do this much, and if you find any difficulty, you can ask us in questions in the comment section. And please like this video and subscribe to our channel so that you can receive more interesting data analysis videos like this. Thanks for watching.